Hi students, in this lecture I am going to discuss problems. Let us see first one. 1 mole of an ideal monatomic gas is taken round the cyclic process ABCA as shown in the figure. Calculate the work done by the gas, the heat rejected by the gas in the path CA and absorbed by the gas in the path AB. Net heat absorbed in the path BC, maximum temperature. Okay. First, let us make diagram for this one. See the graph given. So it is a graph given between pressure and volume. Pressure and volume. Right, we can see. Coming to correspond to this one, volume is V naught, and this is 2 V naught, and this is a P naught pressure, and corresponding to this, it is a 3 P naught. So A, B, and C. Now, say first question, work done by the gas. Since it is now cyclic process, simply focus area under the graph. That means area of triangle, okay, cyclic process. That means see what we get. Half base equal to V naught. Height is 2P naught. That means it is equal to P naught V naught. And this is a positive because it is clockwise, right? It is clockwise. Work done is positive. Next, coming to B, the heat rejected by the gas in the path CA. If you see carefully, C to A, P constant, but volume is now decreasing. Now take gas equation, PV equal to nRT. PV equal to nRT, P constant, volume is decreasing. Volume decreasing means T will decrease. That means heat is now given out. Okay. That's why it is heat rejected. So we have to calculate now heat rejected by the gas in the path CA. So coming to B, in that heat rejected Q from C to A. Since it is now constant pressure, we have take NCP delta T. It is NCP delta T. Then see what we get. N value given 1 mole. CP, it is monatomic gas. CP value 5 by 2 R CP. Delta T. Delta T value, it is C2A. Delta T means we can that temperature is equal to PV by NR. So it is a final value P naught V naught by NR. N is 1 by R minus initial value P naught to V naught by R. Then see what we get. R gets cancelled. It is P naught V naught minus 2 P naught V naught. That means it is minus pi by 2 P naught V naught. That is now heat rejected. Why we got negative means that indicates heat is taken from system. So we have discussed that when heat is given to system, Q is a positive. It is now heat taken from system, right? The meaning of rejected. Now coming to the second part in that, heat absorbed. Coming to heat absorbed, A to B. Heat absorbed A to B. That is equal to A to B constant volume. Constant volume means it is NCV delta T. Constant volume. N is 1. CV monatomic 3 by 2 R delta T. Again T equal to PV by NR delta T. It is A to B. It is 3 P naught V naught. 3 P naught V naught by NR. N is 1 minus initial value P naught V naught by R. That means see how much we get. 3 minus 1, it is 2. 2, 1, 2 gets cancelled and R gets cancelled. It is equal to 3 P naught V naught. Okay. That is now heat absorbed. And see, coming to see what we have to calculate. The net heat absorbed. The net heat absorbed by the gas in the path BC. In BC process, heat absorbed. For BC heat absorbed, we have to calculate. See, what we can do is, for B and C, we know temperatures. That means we can calculate delta U for BC and we can calculate now from B to C how much work is done. So I can take this as a combination of delta U plus W. We can find delta U and we can find W. So first focus W, W A to B. A to, sorry, it is B to C. W B to C. It is B to C work done how much? It is equal to area under the graph. That means triangle plus rectangle. So coming to area of triangle, half base height equal to 2 P naught plus coming to rectangle, it is P naught into V naught. So work done is equal to 2 P naught V naught. Okay. Let us now focus delta U. Delta U value NCV delta T, right? N is 1. CV, since it is now mono, CV 3 by 2 R delta T. Delta T means final value minus initial value, final value P naught 2 V naught upon R, N equal to 1. Final temperature minus initial temperature is 3 P naught V naught upon R. R gets cancelled. It is now 2 minus 3 minus 1. So minus 3 by 2 P naught V naught. That means temperature is decreasing from B to C. Okay. That's why we got here negative. Means we are not saying decreasing continuously when compared to temperature at B, at C, it is less temperature. Okay. So we got negative. Therefore, Q value for process BC equal to This is a 2 P naught V naught. This is minus 3 by 2. Remaining is now half P naught. That is heat absorbed. This is heat absorbed in the process B2C. Okay. Now see in that last one, the maximum temperature attained by the gas during the cycle. See how to calculate that. Maximum temperature. So first we have to focus like A to B, volume constant, P value increasing. That means temperature definitely increases from A to B. Now we have to focus from B to C how T value changing. If we are knowing that, then we can say where temperature is maximum. So let us focus now B to C how it is changing. For this straight line, we can write here line equation. So pressure equal to slope is negative. That slope is minus 2 P naught by V naught. It is just like minus mx plus C, some constant here. See how to know that. Do one thing at B. For B, when volume is T naught, sorry, V naught, pressure must be 3 P naught. Substitute here. If it is V naught, P must be 3 P naught. 3 P naught, V naught gets cancelled. 3 plus 2, 5. That means this constant must be equal to 5 P naught. Okay. So we got now pressure as a function of volume, right? Now use gas equation to find temperature. So temperature equal to 1 by nr into PV. P value 5 P naught minus 2 P naught by V naught into V. Students, if you observe carefully, take this V value inside. It is just like A into X minus B into V square. I will write here once again 1 by nr. It is a 5 P naught into V minus 2 P naught by V naught into V square. Okay. It is of the form AX minus BX square. That means it is a parabolic, right? That means the shape comes like this. So temperature first increases, becomes maximum, then it will decrease. See, we got condition that temperature at C is less than that at B, right? But in between increasing, then decreasing. To know at which location T maximum, now we have to differentiate T with respect to variable that is volume and make it equal to 0. Then see what we get. 5 P naught minus 2 P naught by V naught. Derivative of V square, it is 2V equal to 0. That is equal to 0. Then see remaining calculation. See what's the value of V. Value of V. So value of V, it is P naught gets cancelled. V equal to 5 V naught upon 4, right? Now substitute this value in this expression, then we get corresponding maximum temperature. And see that value how much? After substituting this value there, we are going to get it is 28 upon 25 upon 8 P naught V naught by R. After substituting this value in this one. Okay. Let us see next problem. Alright, see the question carefully. In the figure, a container is shown to have a mobile piston to top. See diagram for this one. This is now container having a piston which can move without friction. And given this piston and this container both are insulating ones. That means from system to outside or outside to system, no heat transfer. Means Q value 0. Now see what he said. The container and the piston are all made of perfectly insulating material, allowing no heat transfer between outside and inside the container. The container is divided into two compartments by a rigid partition made of a thermally conducting material that allows slow transfer of heat. The lower compartment of the container is filled with 2 moles of an ideal monatomic gas at 700 Kelvin, and the upper compartment is filled with 2 moles of an ideal diatomic gas at 400 Kelvin, given heat capacities. This is the question asked in 2014 advance. See the question. Consider the partition to be rigidly fixed so that it does not move. When equilibrium is achieved, the final temperature of the gases will be right. So condition is a partition does not move. So partition does not move means for lower one volume constant and for upper one pressure constant. That means we can write delta Q, that is lost by lower one, that is equal to delta Q, that is gained by upper one. Okay. Lost and this is gained. Coming to lost, it is lost by lower one. And see, you are given lower one is monoatomic, right? 2 moles. It is equal to N CV, right? So it is constant volume CV. N CV delta T. Delta T means 700 minus T. I am taking directly lost. Okay, that's why I have taken like this. Equal to N CP delta T. T minus 400. Okay. Number of moles 2. That's why 2 gets cancelled. CV. Since it is now mono, 3 by 2 R into 700 minus T equal to CP. CP. It is upper one is a diatomic. For diatomic, CP value 7 by 2 R. 7 by 2 R into T minus 400. So R by 2 gets cancelled. So remaining 3 sevens, 21, 2100 minus 3T. That is equal to 70 minus 7 fours, 28. 2800. 70 plus 3T, 10T. That is equal to 28 plus 21, 49, 4900. Therefore, T equal to 490 Kelvin. Okay. Right. Now see the next question. Next question is, now consider the partition to be free to move without friction, so that the pressure of gases in both compartments is the same. Then total work done by the gases till the time they achieve equilibrium will be. Right. See how we are starting this problem. Almost same as previous one, only change is, so here we have to calculate work done total value, but total system Q value 0, right? Because vessel is insulating 1, piston also insulating 1, Q 0. Work done means it is equal to minus delta U. So calculate now first of all what is equilibrium temperature. Then delta Q lost by lower one, that is equal to delta Q gained by upper one. Earlier we have taken NCV delta T for lower one because that time piston was fixed, but now piston is free to move. Means now this also constant pressure. Okay, this also constant pressure. Then see what we can do here. N Cp delta T 700 minus T, that is equal to N at Cp1, this is N Cp2 T minus 400. Number of moles 2, number of moles 2 cancels. Lower is now monatomic. For that Cp value 5 by 2 R, 5 by 2 R 700 minus T, that is equal to, upper one is diatomic, so Cp 7R by 2 T minus 400 R by 2 R by 2 cancels. 5 sevens 35. 3500 minus 5, that is equal to 70 minus 7 fours 28. 2800. So 7 plus 5 12. 12T is equal to 35 plus 28. See how much? 43, 43 plus 20, 63, 6300, right? Then T equal to, it is 525 Kelvin. That is now equilibrium temperature, right? Now we have to calculate delta U value for upper one, delta U value for lower one, then take sum of those two. See delta U for lower one, number of moles to N, CV value 3 by 2 R, delta T means final value minus initial value, final value 525 minus initial value 700. It is 3R, and this is 525 minus 700. It is 175. So minus 175. That is delta UL for lower one. Delta U for upper one. That is equal to N CV. It is now diatomic. CV value 5 by 2 R. Delta T final value 525 minus initial value 400. This is 2 gets cancelled. 5R into 525 minus 400. It is 125. Right. Now focus delta UL plus delta U for upper one. That is now delta U. Okay. So this value how much? 125, 625, 625 R. And this is, now this is 300, 375, 225. It is minus 525 R. So net value, it is 100 R, right? Net value 625 minus 525, net is 100 R. Now work done equal to, it is equal to minus delta U, that is a minus 100 R. Okay, that is the answer. I hope you got a clarity. In the previous one, partition was a fixed. That's why lower constant volume, upper constant pressure. But second case, piston free to move. So both are constant pressures. That's why we have taken NCP delta T for both, right?